Hi, we are engineering brothers. In our previous consideration, we have considered that the pole is placed at our one point over there, or one point of our much needed S plane over here, and quite naturally we do know that what is the S plane. S plane is the consideration of our real value and the imaginary value over there, and the pole location is at the one position over there, and I have already described over there. And in our next part, or in our next consideration, the pole location is considered at our minus one position over there, and quite naturally the equation for this one seems to be our plus one, as we do know that how do you get the considered poles over there if you just do consider the denominator as a 0 point over there. Now in this case we are having s plus 1, that is equal to 0, that ultimately do give us the equation as is equal to minus 1. Now at our minus point location the pole is considered over here. Now this one will be our plus 1 over there. Now once again we do require to consider over here the much needed impulse response over there, and after we have considered the impulse response which is Rs is equal to 1, and we have put that over here once again, ultimately we do give us, or here the considered equation seems to be our Cs is equal to 1 divided by s plus 1 over there. Now if you just do apply the inverse Laplace on that given considered part, we are having the equation as e to the power minus t, and I do know that after we do apply the inverse Laplace on this given equation, we are having the equation or that time domain part as our considered part Ct is equal to e to the power minus t over there. Now according to our considered Ct with respect to time waveform over here, if you just do increase the time, that is tends to infinity, we are having that, or we do know that the output is going towards our 0 over here. It is going towards our 0 over here. Now in this case the system will be stable. Why? Because if you do increase the time, which is time t tends to infinity, the Ct is going towards our 0 for our considered part over here. You do realize that if you do increase the time of our given Ct, in this case or in this pole location over here, what is the pole location? The pole is placed at our minus 1 position over there, and if you just do increase the time, the output waveform that is been going towards our 0, if you just do increase the time, you can do realize or do see that the time is going towards our 0 over here. And as you can see that according to our Vivo consideration over here, as we do have the much needed the boundary output over here, and the output do have our finite value over here, quite naturally we can say that the system is quite stable over here. And how do we consider that? According to our considered pole position, which is the pole is placed at a minus 1 position over there, and after that we have realized that after we do apply the inverse Laplace, the waveform is this one, and just by plotting that over here we can see that the Ct is going towards 0 if you just do increase the time over here. And the same procedure is followed over here. First of all, we do realize that the system do have the poles that is being placed at our minus 1 position over there, and after we have analyzed that the waveform or the transfer function for our given system, which is Gs, the Gs will be our 1 divided by s plus 1 over here, and following to the same procedure over here, in our next step we do put the much needed input, which is impulse response over here, which is Rs is equal to 1, and we have put that over here, and after we have considered that Rs is equal to 1, the equation is Cs is equal to 1 divided by s plus 1. And in our next step, if you just do apply the inverse Laplace in this given considered part, we are having Ct is equal to e to the power minus t, and after we have plotted that same consideration or time domain analysis over here, we are having that this waveform over here, and as the value is going towards our 0 over here, and that is quite naturally the finite value over here, then we can say that the system is stable over here. So this is the considered part over here. Now quite naturally, if you just do compare with our upper and the lower portion over here, you can see that if the pole is placed at the right hand side of our given considered part, then the system do have the considered part over here and the system is unstable. And the same pole, if you just do shift that pole to the left hand side of our given waveform, then the system is stable over here according to our waveform over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos and keep following our channel. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates and stay tuned to the channel. Thank you and goodbye.